All right, so I wanted to go over a couple questions on the Edge Elastic with you guys, for especially e-learners who are doing this at home. So for number one, hopefully you figured that one out. You just got to plug x squared into your calculator. So you should be using your graphing calculator, not the Desmos scientific calculator. You need to learn how to use this calculator. And I will have Desmos blocked when you take your quizzes and tests for this unit. If you don't have a calculator, you need to get one. And if you don't know what calculator you need to get, make sure you talk to me. Okay, you need the TI-84CE Plus calculator. It's about $100. You can maybe find it on eBay if you need to. Okay, let's get to the point. So we're going to type in the function x to the second power. Also, you can skip in this video to see which part you actually need if you're fine on number one. And then I'm going to go to second table. The table button is up here to get to the table of values. Go second table, so second graph. And then I'm looking from -1 to -2 to +2. So that lines up with this point to that point, and the y values are 4, 1, 0, 1, and 4. So 4, 1, 0, 1, and 4. Now notice that we have symmetry. So if you have 4 and 1 on this side and 4 and 1 on that side, and you have 0, 0, that's the middle of the graph. And these are parabolas. So if you were to press zoom 6 and go to the standard window, this is a parabola. That's what the shape is. And this turning point, that middle point right there, is called the vertex. So we're going to be talking a lot about the vertex in this lesson, in this whole unit. Okay, so I'm going to skip to number 5. So the other ones were just ordering. So if you plug it into your calculator and you look at the steepness and look at the order. So now we're talking about kind of the same ones, except they're flipped. So the other ones were all positive from numbers 2 to 4. And if they're positive, then their graphs were opening up like that. But these are negative in front. So these graphs, the parabolas are going to be opening down. Okay, opens down, so the arrows point downward, and it's kind of like a smiley face. I talk about more about that in tonight's lesson video. So it kind of works the same way. The further away the coefficient is from 0, the steeper it's going to be, but they're just going to be flipped. So let's look at how you would graph those. So I'm going to do just one at a time in my calculator. I'm first going to do negative x squared. So in order to graph them on Edge Elastic, we're actually going to look at the table. So the first thing they want us to do is to find the vertex. So the vertex is your middle point, which for us would be at 0, 0, because you see like the symmetry on both sides. So 0, 0, and then you would then plot 1 point away from the vertex. Now in Edge Elastic, if the parabola is opening down, then you want to pick a point to the left. The parabola opens up, then you would want to pick a point to the right. You'll know if you're doing it wrong if you end up with like a sideways parabola. We don't want sideways parabolas. They're either opening up or they're opening down. So the next point to the left would be at -1, -1. All right, so now I'm going to take the parabola button, plot 0, 0, and then -1, -1. Okay, that's what that would look like. Let's do the next one. So now I want -2x to the second. Oh, I always do that on the wrong one. Let's see. Oh, goodness. Pressing the wrong buttons here. Okay, -2x to the second. I'm going to go second table, look for my symmetry. So it's 0, 0 again, but if I go 1 unit out from the vertex, instead of being at -1, we're now at -2. So our axis of symmetry, I'll drag this back over here, is still at 0, 0, but if I go 1 unit away from the vertex, I'm now at -2. Therefore, with the 2 in front, our graph is more narrow, therefore it's more steep. Okay, guess what's going to happen if I replace the 2 with the 3? Okay, let's see. Second table, vertex is still at the origin. If I go 1 unit away from the vertex, we're at -3. Okay, so we'll plot 0, 0, then -1, down 3. And you can guess it, the next one, negative 4x squared, will be at 0, 0 over 1 down 4. Well, that didn't end up like how I expected it to. So what if that happens to you? What you need to do is kind of move your point over. So what if I drag it over here? Still not what I want. What if I just kind of flip-flop the H and the G? Maybe that'll get it to work. So one thing you can do is like go to the graph and see what those should look like, and then match it up. Does the graph and edge elastic look like what it's supposed to? And if it doesn't, then manipulate your points, the order of the points. Okay. Now for this one then, the most narrow would be the negative 4x squared, the least narrow, the widest would be negative x squared. Okay, so for this one, the first one is the same. So y equals negative x squared, you've already done that one. It's at 0, 0, and then if you go over 1, it's down negative 1. Now these other ones are different because they're fractions. So actually the smaller the fraction, then the wider it's going to get. Okay, so here our next one is negative 1/2. So I'm going to delete, actually, I'm going to just clear this whole thing. So negative fraction button. Most of you can do alpha and the button next to it. If that doesn't work, do alpha, y equals, and press enter. But we've got negative 1/2 x squared. And then you press second table, look for my symmetry until where I see my turning point. It's a 0, 0 again. All of these are going to be at 0, 0 because you're not adding or subtracting anything from the x squared. So if I go 1 unit out from the vertex, we're negative 1/2. So the fact that's negative 1/2 and that the coefficient is negative 1/2 is not a coincidence, you guys, if you haven't figured that out yet. So 0, 0 over 1 down 1/2. And then here it's 1/4. So if I plot 0, 0, I go over 1 down 1/4. And then negative 5/4 is negative 1.25. So that's what it should look like. So this one is going to be the most narrow, the one with the coefficient furthest away from 0. And then the 1/4 is going to be the widest coefficient closest to 0. All right, so hopefully that helps you with the other questions. I feel like I already asked you to do that question. Was that not part B on this question? Oh, I guess this didn't have a part B, did it? Okay. All right, so let's do number 8. You should figure that one out. Number 9. All right, so how to do these ones? If you're adding or subtracting something to the x squared. So multiplying by something by the x squared is going to make it become wider or narrower. If you add something to it, then it's going to move it up or down. Okay, and then the b, we don't have a b, but you'll learn in tonight's video, the b makes it go sideways from side to side. But if you add or subtract something to x squared, then it goes up or down. So here, remember our parent function just looks like at the origin and then over 1. So don't graph this. This is our parent function. That's our original function. Now, what changes? Don't actually graph this, okay? I'm just putting this up here for an example, for a baseline. So what happens if we subtract 1 from this function? Let's type it into our y equals and see what happens. So we've got x squared minus 1. And then if I press second table, I'm looking for my middle point, and it's not 0 anymore. It's still at 0, but it's negative 1. The fact that you're subtracting 1 from x squared and that the vertex goes down 1 is also not a coincidence, okay? And then the slope is still the same. So the slope, you still go over 1 and then up 1. But now that our parabola is opening up, we're actually going to not plot a point to the left, but we're going to plot a point to the right. Okay, if I plot a point to the left, then it just makes it go sideways. So that's part A. Part C, you're adding 3. So literally you just need to take all of these points here and move it up 3. So I'm going to replace -1 with +3. And then you can see that the vertex is at 0, 3. And then if I go over 1 from the vertex, I'm at 4. So 0, 3, over 1, up 4. Not like up 4 additional points, but just the next point over is at 4. Okay. And then the vertex point would be that point and that point. So 0, -1, 0, 3. It just depends on what this number is. Okay. And then since the parabola is opening up, these points here are minimum points. Okay? Minimum points. They're at the bottom. Okay, so that should help you with with number 10. I feel like most people, as long as they get number 9 good, they're fine with number 10. Okay, so if you have further questions on number 10, then feel free to ask. For this one, remember that when you have a positive in front, when your function is positive, I'm trying to use the marker, then your parabola opens up like a smiley face. So that would have a minimum point. If your parabola opens down, it's going to have a maximum point. Okay, so make sure you keep notes of those so that you don't get mixed up. Okay, so I hope this video